Today topic is Bernoulli's principle. Bernoulli's principle says in a fluid flow, the net mechanical energy remain constant. Net mechanical energy for here P upon rho g plus V square upon 2g plus z equals to constant, right? So this is the mechanical energy. So this is the this one is the pressure energy, this is the kinetic energy, and this is the elevation head or elevation energy or potential energy of the fluid, right? So right, so this is the pressure energy. So this is the pressure P upon rho g. This is pressure energy. This is the kinetic energy. This is the potential energy. So, but here we know this is next question. What is the uh, but here it is in a meters. Here we know this is the unit meter because z, this is unit z of is unit is meter. So definitely this unit also will be meter. This unit also will be in meter, right? So but energy is not in meter. So so this is the, it means this is energy per unit weight. So this is the potential energy means mgh, right? H, here it is z, so it is z. So this is the weight. So similarly here, so and similarly here, so it is energy per unit weight. So unit is, here it is energy per unit weight, right? So this is the equation. Energy at a point, here I am using some different color so that we can understand easily. For example, here this is the converging diverging tube, right? So so this is the flow field. This fluid is coming here inside. Here fluid, here it is liquid, or here we have taken, we can say it's water, for example. So for energy we want to conserve, we want to measure the net energy at a point, net mechanical energy. For example, this is 1, 2, this is 3, this is 4, and this is 5, right? This is the center line of this converging diverging tube, right? So energy at this point, it means p upon p1 upon rho g plus v1 square upon 2g plus z1, this is equals to p2 by rho g plus v2 square by 2g plus z2 is equals to p3 by rho g plus v2 square by 2g plus z3, right? Here it is v3 because point third is there. So so and so on, right? So what is the first question, that is what is the p upon rho g? P upon rho g, this height from the center up to this level, this is the p upon rho g, and p2 upon rho g, it is second point center of this one and up to this height, right? So when we experimented, when we see, so this line will go down, means here this is converging in a steady state, right? So there are some assumptions. First I'm telling the assumptions here. Assumptions are fluid should be steady. Steady means at a point the field variable should be constant. For example, here What are the field variables? Here, this is the pressure. Here we are talking about the pressure and velocity. So at particular point, for example, this point, pressure should be constant. So means the properties del by del t do not change, uh, should be equals to 0. At a point, the velocity remain constant, right? Means the derivative of this property with respect uh, time derivative, it should be equal to 0 because this is a constant value. So definitely it is, for here it is pressure and other is velocity, right? Here, but here at 1.1, this point velocity may be different. So definitely it will different. V1 less than V2 less than this is V3. V3 will be the maximum because this is the center of the this converging diverging tube, right? So here assumption first should be study. Second assumption is this should be incompressible. Fluid should be incompressible. Incompressible means rho equals to constant. Density should be equals to constant. And third one is fluid should be ideal. Ideal means their viscosity should be equals to 0. And next one is flow should be irrotational. Irrotational means the curl of velocity, this should be equals to 0, right? So when when in experimentally when we'll see, so we will see that here at the point 1, here this value will be highest, right? Because here pipe diameter is larger, so pipe diameter is larger means velocity is less. So velocity is less means velocity head should be lesser. So here it means p upon rho g, p1 upon rho g, this value should be higher, okay, than the p2 upon rho g. And similarly here p3 upon rho g. Here we know because sum should be equals to 0. Here elevation head it is same, means z1 equals to z2 equals to z3 equals to z4 equals to z5, all are the same, right? Because this is same elevation height and this is horizontal. This pipe is horizontal. If it is some angle, so that case it will be different. But here this value is constant, right? So net energy is constant. But experimentally, how we will calculate this value, this is very important, right? So in a here if we know flow rate means if we store this flow in a tank which cross sectional area is a, at a particular time its height we will get h, so at particular time t, so this is a q, and this q will be equals to the cross sectional area. The same flow rate will come from this this tube, so means this should be equals to a1 v1 equals to a2 v2 equals to a3 v3 and so on. So from we know a means the cross sectional area of this converging diverging pipe or a tube. If we, because we know its diameter, so we can calculate the cross sectional area. So we will get the velocity v1 v2 v3, and finally we will put this value here. If we see here, so we will get the energy constant, right? Experimentally. So if this is E1 for point 1, E1 means P1 upon rho g plus V2 square upon 2g plus Z1, right? So it is P1, right? So it is V1, right? V1 plus Z1. So similarly E2 upon rho g plus V2 square upon 2g plus Z2, right? So so finally we will get E1 equals to E2 equals to E3 equals to E4. It means this is the verify the Bernoulli equation, right? So for watching this video, so if you have any doubt or any query, please let me know on the comment section. I will try to answer your question. Thank you very much.